This is HRW97P031, sorry. So the only force acting on a 3.3 kilogram body as it moves along the positive x-axis has an x component of Fx equals negative 6x newtons, where x is in meters. The velocity of the body at x equals 3 meters is 8 meters per second. We want to know what is the velocity of the body at 4 meters per second, and then we want to know at what positive value of x will the body have a velocity of 5 meters per second. Okay, I've got the relevant information copied over to here. Well, let's see. I don't have enough to do a kinematics equation because my force is a variable force. Whenever I see a variable force in an energy problem, the first place my mind goes is, work done by a variable force. How could I use work? Because that's one thing I do know. I know that the work done by a variable force is the integral from initial position to final position of, f of x dx. Okay, that's in one dimension. So, well, I've got, let's see, I've got a starting position, I've got a final position, so I have enough for my limits, that's good. If I got the work, that would be the change in energy, the change in kinetic energy. Well, I could find my initial kinetic energy because I have a mass and I have a velocity. If I could then end the change, I would get a final velocity and I could work backwards and find the velocity. Okay, so let's do that. Well, so I've got the integral of, I want to go from x equals 3 to x equals 4. My function is negative 6x dx. Okay. When I integrate, the constant stays there. The x, well, this is x to the first, really. So to integrate, I take the, if it's a polynomial, I take the exponent and add 1, so I get x to the second, and then I divide by the new exponent, okay? And I still have the same limits from 3 to 4. All right. Well, that's nice. Negative 6 over 2 is negative 3. So what I really have here is that the work done was negative 3, and then I put in these numbers. So I've got x squared, so that's 4 squared is 16, minus, then I put the bottom limit in. So x squared, that's 9, or that's 3 squared, so that's 9. And I end up with negative 3 times, let's see, 16 minus 9 is 7. I hope I'm doing that right. It'd be really embarrassing if I wasn't. And so I end up with negative 21 joules. So that's my change in kinetic energy. All right. Well, my initial kinetic energy is 1/2 m initial velocity squared. Okay. So that is 1/2 times 3.3 times initial velocity was 8, so 8 squared is 64, and I end up with initial kinetic energy is 105.6 joules. Now I know that work also equals the change in kinetic energy, so that's final kinetic energy minus initial kinetic energy. Now the work was negative 21 joules equals final kinetic energy I don't know, but initial kinetic energy was 105.6 joules. So if I add 105 to both sides, I end up with K equals 84.6. Kinetic energy equals 1/2 mv squared. So if I solve for v, let's see, I can multiply both sides by 2, and I get times 2, 169.2 equals m times v squared. Divide both sides by m. M was 3.3, so divide by 3.3, and I end up with v squared equals 51.3. Sound like I'm asking a question. Yeah, 51.3. Okay. And then the square root of that is my answer. Answer 7.16. Come on. Meters per second. Quick check. Yep, 7.16. Alrighty. Now I want at what position would I get a velocity of 5? So this one, I still have the same initial kinetic energy. So I'm not going to redo all. I'm not going to redo all that math, but I do know this. I also know this. Okay. I don't know the work done though. I don't know that yet. But I can find the final kinetic energy. I know that. See, this is now part B. I know the final kinetic energy is 1/2 mv squared, which in this case is 1/2 times 3.3 times 5 squared. Okay, so the final kinetic energy is 41.25 joules, which means the change in kinetic energy, well, that's final kinetic minus initial kinetic. So that's 41.25 minus 105.6. So the change in kinetic energy is negative 64.35. I know that's equal to the work done. And the work done is equal to, if you go back here, it's negative 3 times, let's see, from 3 to x. It's the same equation, but my limits would be from 3 to this unknown x that I don't know what it is. So that's going to be, let's see, if I don't want to flip the page, so I'm going to do this over here in another color. Let's use green. Okay. If I do negative 3, sorry, back up, go on, there we go, negative 3 x squared from 3 to x, where x is something I don't know, that ends up looking like negative 3, well, x squared minus, put a 3 in for x squared, I get 9. Okay, so that is negative 3x squared plus 27. So that goes over here. Negative 3x squared plus 27. Now it's time just to solve for x. So I've got a 27 over here. Let's move it over there. So that's minus 27 on both sides. And I end up getting negative 91.35 equals negative 3x squared divided by negative 3. Come on, whoop. And I end up with, see over here, I get 30.05, or sorry, 30.45, and then I square root that, so I end up with x equals 5.52 meters. Go check that. Yep, 5.52. So that's it.